Today we're here at PCIM 2026 and we have seen some marvelous technologies coming out, everything from SiC and GaN, and honestly it's a great event. But today we're here at the onsemi stand because I've seen something that looks very, very interesting. Now I'm joined by my very good friend Didier. Thank you for having us here today. Now before we dive into the simulation software that you're going to be showing us today, just tell the audience who you are and what you do.
I'm Didier Balocco from onsemi. I'm technical marketing based in Europe, taking care of power product and also promoting our simulation capability that we try to introduce during several years. And here we have released our new tool that fill all missing pieces in simulation. And this tool, we call it Elite Pairing Studio.
So we always see these new technologies coming up, MOSFETs, SiCs, GaNs, all these different kinds of things. What would you say has been the biggest challenge for engineers when it comes to getting these technologies to work?
One of the big challenges to drive those devices. Most of the time we know the device, we know the challenge of the device, but we have also the challenge to drive them. And when it comes to select a gate driver, you don't know how to do. And this is where we fill the hole or close the gap between when you are in the design flow. It's easy to decide which switch you want depending on the power you want to get. But when you want to drive that switch, there's the Elite Pairing Studio is there for that. It will analyze all possible gate driver for the switch you have selected in onsemi portfolio and then give you parameters or value depending on the driver and this switch pair. And then you can decide which one fits your need. Your need may be the maximum efficiency, maybe the low EMI content, maybe the low cost. So we don't know. We give you the ability to select which one will fit your need.
Right, so I actually misunderstood that. That's actually really fascinating. So, as you mentioned, I think a lot of engineers tend to get worked up, maybe, it must be the highest efficiency, but sometimes, like you say, the lowest cost could be the most important factor, yes, or the EMI, and it's funny you mention EMI, because I know personally that GaN and SiC, with their higher frequencies and the larger powers, EMI is a big issue. Yes. And so what you're saying is that your software can allow you to mix and match and then get the data to see how they would behave as a pair.
Exactly. So it's like when you have a race car. The race car is our silicon carbide.
Got that right there, right now, there.
Yes, the race car is the silicon carbide or the GaN. And you need to drive it. So when you drive, you have the tire that, depending on the track condition, if it's wet or if it's dry, the attachment will not be the same. So here, the pit crew will select the right tire for you, depending on the track condition, will be the Elite Pairing Studio.
And so, like you say, so as with different conditions on tires, different conditions for circuits. So if the circuit is, I don't know, operating at higher power, having a higher efficiency may not be a good thing. It may be better to use a different gate driver for that.
Yes, exactly.
And so, can you just sort of go through like how that software is doing that? How are you able to have all these different parameters, and how do you mix them together? Is it simulation or?
It's a mix of simulation and calculation. So we say human intelligence. So at the beginning, we use simulation to extract the parameters of the device you will select. We have also a table of parameters for the gate drive, and we mix all of that with equation at the first step to give you this table where you can select. Then when you make the selection, you move to the second step that will simulate this pair and give you all the waveform that you can imagine. And then we will, in the future, also include FFT of those waveforms to get to EMI. And also you can get the Plex model out of this tool and send the Plex model to the topology simulator that is called Elite Power Simulator, and then get the complete picture of your system.
And so I'm kind of guessing that, let's say as an engineer, I have a selection of devices, switches, and a selection of gate drivers. I would put them through the tool, get all the different bits of data, and then from there I could decide which path to go, because like you say, maybe the efficiency is good or maybe the EMI needs to be low. So would that tool immediately sort of warn me like, oh, this could be quite a bad pair and this could be a bad pair?
No, not for the moment. It's a lot more.
Not for the moment, maybe in the future.
Yeah, this is something we are, let's say, maybe we'll analyze for the future. For the moment, we are at the alpha version of the tool. We have decided to release the tool at PCIM to show what we can do. We will include much more in the future, much more capability of the tool. We have a lot of ideas to include in it. This approach also is one thing we want to include in the future, but give us time to make more addition to the tool and be even more powerful.
But right now, that tool can already be useful for engineers.
It's fully ready to be used and fully functional without bug, nothing.
So if, let's say, you're an engineer and you're watching this video and you want to get on with this tool and start using it, what would they do and how could they get involved with onsemi solutions?
It's straightforward. You go to onsemi.com, you go to the main menu design and you select Elite Pairing Studio. The only thing you need is my own account to enter the tool, to get the user guide, the application note explaining how the tool works, and then you are ready to go.
Fantastic. And my last question for you is, as we go into the future with all these new technologies coming up, what would you say is like the most exciting application for you for these tools?
There's many exciting applications where the tool fit, but I think AI is one of them where they need very accurate result to predict, and as the density is really important and the efficiency is really important, I hope this tool will help a lot, but also in any case, because maybe a customer who want to make a very low-cost system for the, let's say, for anything low cost or something, will be interesting for him, or even in industrial application or automotive application, maybe to extend the range of the car, there will be compromise that will extend the range of the car that we cannot figure. Maybe it will be the efficiency, maybe the light.
And I think it's interesting you mentioned again, it's that choice, because in a car you may want efficiency, but let's say an AI data center, you actually might want reduced EMI because that might then affect the RAM, the CPUs and everything else. So, and again,
the communication on the bus. Everything.
Exactly, and what this tool is giving engineers is it's saying to engineers, yes, you can maximize efficiency, but there may be other things you need to maximize instead as a trade-off, and your tool will make sure that they can always get the lowest EMI or the lowest efficiency or something else that will help them empower their solution. Well, all I can say is this has been an absolutely fantastic demonstration, and thank you ever so much for having us here today.
Thank you so much.
Thank you so much. Thank you.